Hello and welcome to this conversation with Saeed Anwar. My name is Frank Rayal. This conversation is part of a Sensafili report on small cell backhaul that gives an update on the small cell backhaul solutions and on the evolution of mobile operator requirements for small cell backhaul. Today we're talking to Saeed Anwar, CTO of SOLiD Technologies. SOLiD is a leading provider of advanced distributed antenna systems, commonly known as DAS. Saeed, welcome to this conversation. Thanks for being with us today.
Good morning, thank you.
I would like to start by asking you a brief introduction about SOLiD Technologies.
Yes, SOLiD is from South Korea. Our R&D and manufacturing is done in Seoul. And the US portion is sales, marketing, and logistics for distribution of the product into the US and North American markets. We are primarily selling DAS, both indoor and outdoor DAS in North America, and we also have fiber optics for fronthaul and backhaul.
So in terms of the products that you're providing specifically targeted at the small cell solutions, I believe that's called the Infinity Access.
Yes.
All right. Can you provide us, help us position this product, tell us what it does and some of the features of that product.
Okay, so the product itself is a DWDM, dense WDM technology product. It has the capability of channelizing a single fiber strand into multiple bidirectional channels. The technology itself can handle 32 bidirectional channels, but currently the form factor that we use allows us to do 16 bidirectional channels. So with a single fiber strand, what we can do from the hub site, where all the heavy equipment is, we can take the signaling and transmission over a distance and do 16 linear add drops off that single fiber to wherever the small cells are, whether they're on a wall or lamp posts or other street furniture.
Okay, that's interesting. Now, when talking about the type of the DAS systems and specifically your product, because I think it's slightly different from the standard DAS solutions, and I will get into that later in this conversation. But you mentioned fronthaul. Fronthaul is a relatively new name in the industry. Can you tell us a little bit more about what fronthaul is and how you define it?
Yeah, so fronthaul, let's start off with backhaul. Backhaul is basically from a small cell, whether it's an E node B or a microcell, or the typical protocol that you use is over Ethernet, going back into the core. Well, the base station itself is actually split in two parts. There's the baseband processing, and then there's the antenna system itself, which we call the remote radio head. The protocol between those is what's called fronthaul. So it's designed, traditionally it's designed for macro deployment, where you have the baseband unit at the base of the cell tower, and then you have the remote radio heads at the top. It is a fiber-based system using a protocol called CPRI. And from there, people have learned that you can actually take that remote radio head and distribute it wider. Some people are deploying it over distances of tens of kilometers. And that is basically what we refer to as fronthaul in the industry.
Mm-hmm. So how about the applications of the Infinity Access? Can you describe a few deployment scenarios of how the system can be used?
Yeah, so as I said, the small cell deployment, that's one scenario. Using a single strand of fiber, you can do 16 linear add drops on that fiber to street furniture where the small cells are. That that linear add drop can simultaneously handle both backhaul and fronthaul. Other deployments where we use Infinity Access is in regular, what I would consider telecom or enterprise environment, where you have fiber shortage or fiber capacity shortage, and you want fast relief without retrenching or blowing more fiber. It's an easy way to add capacity on that fiber run.
Mm-hmm. So in terms of the deployment of your system, let's say I have a base station from a vendor A, and then I want to cover, let's say, a certain area, whether it's indoor or outdoor. What are the interfaces, and how do you deploy? How does your product fit within the greater scheme of having a base station on one side and antenna on the other side?
Well, the protocol for that particular scenario, as I said, it is CPRI. There is another version called OBSAI. The scenario for that is really, at the current time, more outdoors. Obviously the macro cells are split into baseband and remote radio head, but also what we're seeing is a new form of microcell, basically 1-watt systems that are considered small cell and also have the same fronthaul interface going back into a data center.
Mm-hmm.
So those two are the primary scenarios that we see.
Mm-hmm. I'm just trying to visualize this thing. Let's say if I have, or maybe I should ask, where do you see most of the deployments of your system, the Infinity Access? In what type of environments do you see the operators deploying that?
We see that in metro areas for small cells, microcells, where you're trying to provide coverage in a concentrated area. And then from a macro perspective, we also see a deployment scenario where you're deploying macro sites. For efficiency, you're trying to take the baseband processing and centralizing it into a small base station hotel.
Mm-hmm.
So there's the two scenarios there.
Okay. Now the system, I'm just trying to understand here a little bit better. When it comes to DAS systems, they basically interface with a base station. They take RF and they digitize it and put it on fiber, right? And then they go to the other side and they take the fiber back to RF and transmit that.
Yeah.
What does specifically the Infinity Access? Can you put straight baseband on that and go RF to the other side, which is the remote radio head type of scenario? But can you also share base stations from different operators on your system, or is it a single operator product?
No. So I think there's two different types of conversations that we're having. From a DAS perspective, what we're seeing is Infinity Access would be used for a next generation technology product, where we can simultaneously carry multiple bands and multiple protocols for a distributed antenna system. That product we don't have existing today. What we have, like you're saying, is an analog DAS product, where we take the base station input in an analog RF form, and then we mix it, and then send it over our fiber. That fiber system that we have currently for the DAS is not Infinity Access. That is basically an analog fiber system using, again, it's using WDM, but it's not using dense WDM.
When it comes to small cell backhaul, wireless has been widely promoted because the fiber infrastructure can be not as extensive as to reach every single point where the small cell is going to be deployed. With your type of solution, do you see that being deployed mainly in indoor environments or outdoor? And how do you make the business case for it in the outdoor case where the availability of fiber can be an issue?
Yeah, so certainly for indoor deployments, we can use the Infinity Access. For outdoors, we certainly in the metro areas we see a lot of fiber. Outside of the metro areas, yes, fiber is questionable. But because the way Infinity Access is designed, it's very efficient use of the existing fiber. So we can certainly use Infinity Access in a metro environment, but where the fiber doesn't exist, for example, if you want a small cell on the other side of a street, but the fiber is on one side, then yes, we would see the use of things like NLOS technology to basically bridge the gap.
Mm-hmm. Now, you mentioned in terms of scalability of your DAS solution, you mentioned you can add or you can put 16 channels on one fiber strand. Is that per hub? I believe your hub is called the optical line terminal. Is that the capacity of a card, or is it the hub capacity?
That's the hub capacity.
All right. And in terms of the 16 channels, that can be anything ranging from CPRI to Wi-Fi or Ethernet or any other type of channel. Is that correct?
Yes, the primary channels protocols that we use on the fiber are CPRI and Ethernet, yes.
And
Wi-Fi we run over Ethernet.
Okay. What are some of the other main features, and how do you compare your DAS solution to others?
I think there's several factors. The biggest factor is the single use of fiber for multiple drops. Second is we have within the Infinity Access, when we do the linear drops, we have what we call passive bypass of the site for maintenance issues or power outage. So if you imagine if you have 16 drops down the street and one of your cell sites there is down because the power in the building or that lamppost is out, the other sites are totally unaffected because of the passive bypass.
Mm-hmm. All right. So when you look at DAS systems, what are some of the key differentiating parameters? Let's say if I'm going to look at a DAS system, if I'm going to compare product A, B, and C, what should I be looking for? And after that, please tell me, where does your solution differentiate on these parameters?
Okay, so I think from a DAS perspective, the parameters you're looking for is one, the distribution coverage from a single point to a multi-point environment. What is the capability of the system to provide the widest coverage per sector, RF sector that you're bringing in? That would be one. The efficient fiber usage would be a second one. The ability to mux in both public cellular signals and public safety at the same time would be 3. And then another, obviously there are several KPI metrics that you would have to consider for a DAS, RF KPI metrics. But another one that is significant is how you roll individual cell providers onto the system. And that's basically what we call our power level settings for existing carriers after you bring on new carriers. So there's a form of protection for existing carriers there.
Mm-hmm. Very good, thanks. How do you see the, let me go back and rephrase, it seems a debate on what is a small cell, and many people also consider remote radio heads as being small cell, which is in the pure definition in LTE advanced it is. How do you see where do you see operators deploying remote radio heads versus compact base stations? And how do you see the backhaul to these two things playing?
Well, there's different scenarios. Obviously, SOLiD has a very extensive remote radio head deployment within South Korea. But in the US, what we're seeing remote radio heads, one is for hotspots. The other one, which I recently learned, is there's a big deployment of remote radio heads in North and South Dakota because the population increase is so rapid there. So I think the basic reason for deploying remote radio heads, it's an easier way and a faster way to deploy RF without having all the elaborate balancing issues with basically compact base stations. With compact base stations, you still need to make sure that all the interference issues are cleared up. With remote radio heads, you can deploy a lot of remote radio heads, especially if they're in the same baseband, without any interference. So it's an easier technology to deploy from that perspective.
And in terms of the economics, do remote radio heads have an advantage in certain type of a deployment over the compact base stations? And how do you see that playing? And how does the DAS system itself, or the backhaul over fiber, play in that type of a scenario?
I think from an economics perspective, compact base stations and remote radio heads, I would say, would be, depending on how you distribute, would be equivalent from a CapEx type perspective. But from an OpEx perspective, I think the remote radio heads would be easier to deploy, even more than compact base stations, primarily because of all the analysis that you'd have to do for RF interference issues. For the backhaul, I think the compact base stations would be easier from the perspective that you have multiple tools in your tool bag for compact base stations because you're carrying Ethernet. For remote radio heads, you definitely need fiber.
Absolutely. I think that's one of the major issues that when it comes to remote radio heads, we're talking about gigabits per second in terms of throughput. And when we talk about compact base station, we're talking about the hundreds of megabits per second or tens of megabits per second.
Yeah.
Very good. So in terms of evolution and roadmap of your product, where do you see this product heading?
We certainly believe that Infinity Access is going to be deployed for small cells in high density metro areas where there are existing fiber providers there, a substantial fiber plant. We also plan on evolving the technology, like I said, for our next generation digital DAS systems that will combine the ability of carrying compact base stations and remote radio heads into what we call multi-band, multi-protocol systems.
Mm-hmm. Now, can you go back and again detail for us a little bit more on the difference between the analog DAS and the digital DAS? I think that's a key point that would be interesting to understand better.
Yeah, so in the analog DAS system, the multiple bands and multiple protocols, what we do is we take all the feeds from the base stations and we combine them in our RF mixer, and then we translate that RF from coax to fiber, and then we place that particular feed, once it hits the fiber, onto a WDM frequency, and then carry that frequency over a distance. It's very similar to a cable plant. You know, when you're receiving Cat TV signals in your home, from the hub site, you're coming out fiber, and then eventually you go coax right in front of your house. So the DAS fiber system is very similar in that what we feed the fiber, and then the fiber node is what we call the remote node, and the remote node converts the fiber to a coax run, which then goes to your antenna. So it's very similar to a cable plant.
Mm-hmm. And in terms of the your view on the market and the small cell market in particular, whether it's an RRH or whether it's a compact base station, how do you see that evolving, and where do you see some of the main deployments happening right now? And if you can expand a little bit on that.
Yeah, so obviously in heavier density areas, the distances between let's just say cell sites is much smaller than say in rural and suburban areas. With the deployment of LTE Advanced, we see those cell sites, the distance is shrinking further, and the primary reason for that is if you consider cell sites today, they really don't talk to each other. They're talking back to the core. In LTE Advanced, they'll be able to talk to each other, and when they do, if the system is designed to basically, if two cell sites are talking to each other, and if the system is designed so that that connection goes back into the core and then comes back out again, there's going to be substantial latency issues. So with that respect, that's where we see the advantage of our particular technology, because it is ultra low latency. From an end-to-end connection basis, our latency, not including the fiber, is basically around 120 nanoseconds. And our jitter is also extremely low, 6 nanoseconds. So when you total that up, we provide a very good environment for LTE Advanced compared to other technologies.
Yes, that's absolutely very true, especially when considering some of the features that LTE Advanced has, like coordinated multipoint that requires very close synchronization between the different base stations or the transmitters. So I can see that your type of solution would play very well in that kind of a setting or that kind of a technology. That's very good, Saeed. I think any other thoughts that you would like to add in terms of your product line and where you think you're heading with the solution?
Obviously, small cells includes Wi-Fi also. So we're using the same technology to provide Wi-Fi within the same environment as DAS. For example, if you take a sporting event, when you deploy cellular signals, most of the venues are also asking for Wi-Fi, not just from an offload perspective, but because they're also providing other services within the venue, like video. There's a lot of traction on video, things like replay, instant replay to keep the fans within their seats. So we're also taking Infinity Access as a first stage, even before our digital DAS, and moving forward with the Wi-Fi within stadiums.
Mm-hmm. And obviously with your type of system, you can put Wi-Fi, you mentioned LTE, whether it's a remote radio head or if it's a compact base station, and all that can be multiplexed on a single fiber strand and distributed to multiple locations.
Correct, yes.
And how many, it probably depends on the capacity, but how many different remote nodes can you put from one of your OLTs?
Well, 16, but we're also looking at an upgrade to our remotes that basically terminate on the Wi-Fi access gear to provide multiples of those.
Okay, I understand. That's because of it's 16 channels, but let's say if one of the channels can be very high capacity, then you can be more capacity limited rather than the limitation is physical.
Right.
Is that true? Okay, very good. All right, Saeed, well, I would like to thank you very much for being part of this conversation. This conversation is part of a Sense-Affili report on small cell backhaul that provides an overview of the small cell backhaul solutions, along with in-depth conversations like this from leading vendors who opted to participate in the report. The report can be downloaded from the Sense-Affili website at www.senza-fili.com. I would like to thank the audience for joining us today. And Saeed, again, thank you very much for being part of this conversation.
Thank you.